about structure. Example, consider the structure formula of methane. This structure formula of methane shows that the shape of this compound is tetrahedral. Secondly, it shows that one carbon atom is bonded to four hydrogen atoms, while molecular formula of any compound shows the total number of atoms. For example, the molecular formula of methane is CH4. It shows that there is one atom of carbon and there are four atoms of hydrogen present in a single molecule of methane. Thus, we learn that structure formula shows the arrangement of atoms in any compound, while molecular formula shows the total number of atoms present in a compound. Hence, noted down these fundamental concepts. Now, what are isomers? Well, I always teach this simple analogy. Consider these gloves. We know that this glove has four fingers and it has one left thumb, while this glove has also four fingers and it has one right thumb. I say both the gloves have four fingers and a thumb, but they have different arrangement. Now listen carefully. Gloves are isomers of each other because they have same number of fingers and different arrangement. Let me repeat it. Gloves are isomers of each other because they have same number of fingers and different arrangement. So the easy trick to remember the concept of isomer is they must have same number of fingers. There are 10 hydrogen atoms present in it. So the IUPAC name of this compound is N-butane. On the other hand, there are also 4 carbon atoms present in it, while there are also 10 hydrogen atoms present in it. Here, I write 1, 2, 3. The methyl CH4 is bonded at the second carbon. I write 2-methylpropane. Now listen carefully. This compound and this compound have the same molecular formula C4H10 but different arrangement. So they are isomers of each other. Let me repeat it. This compound and this compound have the same molecular formula C4H10 but different arrangement. So they are isomers of each other. Thus remember that these both compounds have same fingers or molecular formula, but they have different structure formula or different arrangement. Therefore, we define isomers as the chemical compounds which have the same chemical formula but different structure formula are called isomers. For example, N-butane and 2-methylpropane are isomers of each other because they have same molecular formula but different structure or different arrangement. Thus noted down this easy concept of isomers. Here, let me ask you one of my favorite questions. What is the difference between isomerism and isomers? Well, believe me, many students know its definition, but they do not know its concept. Let's consider hands and a nose. I say isomerism is possible in hands because we have one left hand and one right hand, or one left isomer and one right isomer. Secondly, I say that isomerism is not possible in a nose because we have only one nose. It has no other isomer. Therefore, personally, I say that isomerism is the tendency, ability of any compound to form different compounds having different structures. For example, our hands have the tendency to form two compounds having different structure, while isomers are the outputs of isomerism. For example, consider CH4. We say that isomerism is not possible in CH4. so it has no isomer. Thus remember that isomerism is the phenomena or tendency of a compound to form different compounds having different structures, while isomers are the output of the isomerism. Here, remember this bonus point. Isomers have different physical properties. For example, consider these two isomers. This is alcohol and this is ether. We know that they have same molecular formula, but they have different structures. That's why they have different physical properties. For instance, this is liquid and this is a gas. Therefore, we say that isomers have different physical properties. Now we will learn the type of isomerism. Well, there are two types of isomerism: structural isomerism and stereoisomerism. Structural isomerism is further divided into six categories, like chain isomerism, position isomerism, functional group isomerism, metamerism, tautomerism, and ring chain isomerism. While stereoisomerism is further divided into two categories, geometric isomerism and optical isomerism. Hence, these are the 8 different types of isomerism. Now we will learn chain isomerism and position isomerism. Well, those isomers which have different number of carbons in main chain are called chain isomers. The easy trick is the main chain or the parent chain of carbon must be different, while those isomers which have same functional group attached at different position are called position isomers. The easy trick is functional group at different position means position isomers. For example, consider butane. We can see that there are 4 carbon atoms present in the main chain. Remember that if the carbon chain is straight, we call it N chain. So this is N-butane. Now I will cut this carbon from the main chain and I will attach it at the second position. I get this structure. Here, 1, 2, 3. This carbon is present at second position. Remember that if methyl group is present at second position, we call it iso. So this is isobutane. Now listen carefully. In this N-butane, there are 4 carbon atoms present in the main chain or parent chain. While in this isobutane, there are 3 carbon atoms present in the main chain or parent chain. According to this trick, these isomers have different carbon atoms in the main chain, so they are chain isomers. Thus we write 1 and 2 are chain isomers because they have different number of carbons present in the main chain or parent chain. Now consider pentane. I only consider the straight chain of pentane. We call this N-pentane. Secondly, I cut this carbon and I attach it to this second carbon. I get this structure. Here, 1, 2, 3, 4. The methyl is present at the second carbon. I call it isopentane. Thirdly, I cut this carbon and I attach it to this second carbon. I get this structure. Here, 1, 2, 3. Remember that if there are 2 methyl groups present at the second carbon, we call it neo. Hence, this is neopentane. Now listen carefully. We can see that there are 5 carbon atoms present in the main chain of this compound. There are 4 carbon atoms present in the main chain of this compound. And there are 3 carbon atoms present in the main chain of this compound. According to this trick, these isomers have different carbon atoms in their respective chains, so they are chain isomers. Thus 1, 2, and 3 are chain isomers because they have different number of carbons in the main chain or in the parent chain. Hence note it down. Now consider these isomers of hexane. This is a straight chain of carbon atoms. There are 6 carbon atoms present and 8. We call it N-hexane. Secondly, I write 1, 2, 3, 4, 5. The methyl group is present at the second carbon. We call it isohexane. Thirdly, I write 1, 2, 3, 4, 5. The methyl is present at the third carbon. I write 3-methylpentane. Fourthly, I write 1, 2, 3, 4. One methyl is present at the second carbon and another methyl is present at the third carbon. I write 2,3-dimethylbutane. Lastly, I write 1, 2, 3, 4. Here, 2 methyl groups are present at the second carbon. We call it new hexane. Now I write the number of carbon atoms in the main chain. There are 6 carbon atoms in the main chain. There are 5 carbon atoms in the main chain. There are also 5 carbon atoms in the main chain. There are 4 carbon atoms in the main chain. And there are also 4 atoms in the main chain. Now listen carefully. 1, 2 and 4 are chain isomers. Because first isomer has 6 carbons in its main chain. 2 or 3 has 5 carbon atoms in its main chain. So we call it chain isomers. Secondly, we can see that second and third have 5 carbon atoms in the main carbon chain. They are not chain isomers. But wait a minute. Here, the methyl group is present at the second carbon, while here, the methyl group is present at the third carbon. According to the trick, the main chain has 5 carbon atoms, but the functional group CH3 is at different position. So they are position isomers. The second and third are position isomers. Similarly, in the fourth isomer, the main chain or parent chain has 4 carbon atoms, while the fifth isomer has also 5 carbon atoms in the main chain. Here, the 2 methyl groups are present at the second carbon and at the third carbon, while here, the 2 methyl groups are present at second carbon. These both isomers have same carbon chains, but functional groups are present at different position. Hence, fourth and fifth are also position isomers. Hence, note it down. Finally, consider these isomers. Pause the video and try to find the isomerism. Well, they both have the same carbon chain, having 3 carbon atoms in the main chain. But here, the chlorine is present at the first carbon, and here, the chlorine is present at the second carbon. So they are position isomers. Secondly, this compound has 4 carbon atoms in the main chain, and this compound has 5 carbon atoms in the main chain. So they are chain isomers. Thirdly, the double bond is present at the second carbon, while here the double bond is present at the first carbon. So they are position isomers. Fifthly, the main chain has 1, 2, 3 carbon atoms, while here 1, 2, 3, 4, 5. Here are 5 carbon atoms. So they are chain isomers. Therefore, remember that chain isomers have different number of carbon atoms in the main chain, while position isomers have the same functional group bonded at different position in the same carbon chain. Now we will learn the third type of isomerism, which is known as functional group isomerism. Well, those isomers which have same molecular formula but different functional groups are called functional group isomerism. In order to spot functional group isomerism, always look at these two conditions. Firstly, the two compounds must have the same molecular formula. Secondly, the two compounds must have different functional groups. For example, consider aldehyde and ketone functional group. Now I look for the molecular formula of the compounds. The molecular formula of this aldehyde is: there are 3 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. The molecular formula of this ketone is: here are also 3 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. Secondly, the functional group of aldehyde is COH and that of ketone is COCH3. They both have different functional groups. Thus, this aldehyde and this ketone are functional group isomers of each other. Now consider carboxylic acid group and ester functional group. As usual, I look for the molecular formula of the compounds. In this carboxylic acid, there are 3 carbon atoms, 6 hydrogen atoms, and 2 oxygen atoms. While in this ester, there are also 3 carbon atoms, 6 hydrogen atoms, and 2 oxygen atoms. Secondly, the functional group of carboxylic acid is COOH and that of ester is COO. They both have different functional groups, so both the conditions are fulfilled. Thus, this carboxylic acid and this ester are functional group isomers of each other. Now consider ether functional group and alcohol functional group. As usual, I find the molecular formula of compounds. In this ether compound, there are 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. While in this alcohol compound, there are also 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. Secondly, the functional group of ether is O, and that of alcohol is OH. They both have different functional groups. Thus, this ether and this alcohol are functional group isomers of each other. Lastly, consider alkene functional group and cycloalkane functional group. I find the molecular formula of these compounds. In the alkene, there are 4 carbon atoms and 8 hydrogen atoms. While in this cycloalkane, there are also 4 carbon atoms and 8 hydrogen atoms. Secondly, the functional group of alkene is double bond and that of cycloalkane is single bond. Both the conditions are fulfilled. Thus, this alkene and this cycloalkane are functional group isomers of each other. To summarize this whole concept, we have learned that functional group isomerism exists between aldehyde and ketone, carboxylic acid and ester, ether and alcohol, alkene and cycloalkane. Thus remember that functional group isomers are those isomers which have same molecular formula but different functional groups. Now we will learn the 4th type of isomerism, which is metamerism. Well, when different alkyl groups are bonded to the same functional group are called metamerism. The condition is same functional groups and different alkyl groups. Here the question is, what are alkyl groups? Well, consider methane CH4. When we remove one hydrogen from methane, we get CH3 and we call it methyl. Secondly, consider ethane. When we remove one hydrogen from it, we get CH3CH2 and we call it ethyl. Thus, by this way, we can form alkyl groups. Remember that alkyl group is represented by R dash. Now consider ether functional group. The ether group is R dash O dash R. Here, let this is the left hand side of this ether and this is the right hand side of this ether. At the left side, there is ethyl, while at the right side, there is also ethyl. This ether contains 2 ethyl groups. We call it diethyl ether. Now listen carefully. I shift this CH2 from the left side to the right side. Let me repeat it. I shift this CH2 from the left side to the right side. I get this new compound. Here, in this compound, this is the left side and this is the right side. At the left side, there is methyl group, while at the right side, there is propyl group. I write methyl propyl ether. Now listen carefully. These two compounds have the same functional group, which is ether. But at the left side of this molecule, there is ethyl.
Why is that on your car?
He earned it. What's the bet? You lose, you wear the L.
At the front of the car or the back?
Extreme 250R. Conquer anything. On 2 wheels or 4.
Ethyl. While at the left side of this molecule, there is methyl. According to the condition, these molecules have same functional group, but different alkyl groups are attached to it. Thus we call them two metamers of each other or two isomers of each other. Hence note it down. Now consider amine functional group. We know that the functional group of amine is R-NH-R. Let this is the left side of this compound and this is the right side of this compound. At the left side, there is ethyl group, and at the right side, there is also ethyl group. So we call it diethylamine. Now I shift this CH2 from the left side to the right side. I get this new compound. Here, at the left side, there is methyl group, while at the right side, there is propyl group. So we call it methyl propylamine. Lastly, I cut these two carbons of the propyl. I attach it to this carbon. I get this new compound. Now at the left side, there is methyl group, while at the right side, there are two methyl groups bonded to second carbon. We call it isopropyl. Thus we get methyl isopropylamine. Now listen carefully. These three compounds have the same functional groups, which is amine NH. At the right side of this compound, there is ethyl. And at the right side of this compound, there is isopropyl. Hence the condition is fulfilled. Thus these three are metamers, are three isomers of each other. So note it down. Finally, consider ketone functional group. We know that its functional group is R-CO-R. Now consider these two compounds. Pause the video and try to find its isomerism. Here I write 1, 2, 3, 4, 5. The functional group of ketone is present at the second carbon, so we call it 2-pentanone. Now listen carefully. At the left side of this compound, there is ethyl group, while at the left side of this compound, there is methyl group.